Bismillahirrahmanirrahim. Today we shall continue with Chapter 1, Topics of Algebra 2. And this is about quadratic functions. Okay. Before I have talked about what it means for a function to be a quadratic function. And we have talked about the fact that all quadratic functions are parabolas. And the parent equation for a quadratic function was y equals x squared. So that's the parent equation for parabolas. And from this we learned a lot of things, such as this would be like example for, it's not the, this is the graph of y equals negative x squared, which is like the mirror image of this graph. So that's the parent function for parent function for quadratic functions. Okay. Today I want to extrapolate on some of this knowledge that we have previously learned and talk about different forms of the way we write quadratic functions, different ways we write quadratic functions. And as a review, I just wanted to suggest remind you about a few things. Okay. So here's a parabola. So every parabola has a vertex, like this, okay? This is the vertex. And the vertex is an ordered pair. Now we call this as Vx and Vy. Many books call this H and K. Vx being H, Vy being K. Whatever you call it, it's an ordered pair that represents the vertex, the very special point right there. I tell the students that as soon as you have the vertex, as you know the vertex, just draw the axis of symmetry, right? So this is the axis of symmetry, axis or line of symmetry. I mean, it's really important because it's like, drawing, a scene without, a beautiful scene without the sun or something like that. It's just not complete. Just draw the axis of symmetry. And you notice axis of symmetry is a vertical line, and all vertical lines have equations of x equals something. In this case, because axis of symmetry goes through the Vx, so the equation of this vertical line would be x equals Vx. That's actually very important to understand also, that the equation for the axis of symmetry will be this. Okay? Now, axis of symmetry, of course, divides the graph into two halves. This half is a mirror image of this half. Right? That's easy enough to understand. Now, these 2 points right here, okay, this point and this point, are the x-intercepts. Okay, correct? So that's like, let me just like this. That's the x-intercept. Okay, and if the graph is like this, there are going to be two of them. They're called S1 and S2. Why are they called S1 and X2? I don't know, but that's what they're called. You can call them something else if you like. S1 and S2. Those are two x-intercepts. Okay. Now you also understand that it does not have to have an x-intercept. A quadratic function does not have to have an x. What if the graph looked like this, right? Then it won't have any x-intercepts. That's okay, right? So a parabola can have two x-intercepts or have none, or sometimes it can just have one, like this. You would have only one x-intercept because it only has one point it touches. So there's 0 over here. There's one x-intercept here and 2 over here. Okay? So those are some of that's kind of like the anatomy of a parabola. It's kind of important. No. Now, this parabola right here, the vertex over here, this is like the highest the function will go. In other words, for every given x value, the y value is climbing here, right? And after this, it's actually like going down. It's getting smaller. So this value here is like the maximum value the function will have. Okay, so in this case, called the maximum value. The maximum of the function. Now the maximum of the function is actually the vy, the y value. It's like the highest pay, or the height of the jump, the highest the ball reached, or something like that. It's the height. If its parabola is a u like this would be like the minimum of the function. So the y value of there. Okay. So if somebody says, what's the maximum of this function, and if the student answers like 2, 3 or something like that, that's wrong. It's this value, that's the maximum. It's the y value of the function. Okay. If somebody says, what's the highest the function reads, and what's the ordered pair there, then you write the ordered pair. But that's just terminology. So this is the basic anatomy of a quadratic function. Okay, we need to understand that. Now, there are 3 ways to write a quadratic function. There might be more, but these are the common ways. Okay? And here they are. The first way is this. Okay? Now this is called the standard form. Okay? And the second way is this. And this is the easiest form, and this is called the vertex form. Okay? And the third way is this. And this one is called, because it has the x-intercepts, okay, it's called the X-intercept form. Okay? It's called the X-intercept form. And if you want to find the vertex of a function that's given to you in the standard form, you need to know this formula right there. Vx equals opposite of b over 2a. Now, this is like the heart of this chapter. You kind of have to like know this. So, just do me a favor, just write this down 3 times or something if you're not comfortable with it. And familiarize yourself with these 3 forms. And if you need to write them more times, just do it. Do whatever it takes to like know them, okay? So these are the 3 ways to write a quadratic function. When we say 3 ways, in other words, every quadratic function can be written in these 3 forms. It's like a person can write their name, first name, middle name, last name, or they can write last name, middle name, first name, or they can write last name, comma, first name, and then middle name. So these are just different ways of writing the equation of the same function, or a quadratic function in different forms. Okay, so we have talked about some of these before. And I'm going to review them, and I'm going to focus today also on the last part, which we have not focused on as much before, which is the X-intercept form. Okay, now look at this one then, the standard form. What the? Excuse me for a second. Okay, here's the standard form. Back in operation. For f of x equals ax squared plus bx plus c. Now, you understand a, b, and c are some numbers. There's some constant. The a and b are coefficients, and that's the constant term. A is the coefficient of the leading term, or the leading coefficient. Now, because what is a? It's a number, okay? It's a very important number because that's the number that determines if the function is going to be a u or an n, right? Y equals 2x squared is going to be like this. Y equals negative 3x squared is going to be like this, right? So it's a very important number. It's just a number. It's very helpful in graphing these functions. It's not the x-intercept necessarily. It's not the y-intercept necessarily, anything like that. It's a number. Okay? Now, here's an example of a function that's given in this form. X squared plus 4x plus 3. See, now you recognize that this is a quadratic function. It's going to be a parabola. Okay, a in this case is 1, b in this case is 4, and c is 3. right? That's pretty easy enough. Because the a is 1, it's not written over there, but it's there, and that's the b, and that's the c. To graph this function, okay, to graph this function that's given a standard form, first you have to find the vertex. And the way you do that is first you find the x-coordinate of the vertex, and then you use that to find the y-coordinate of the vertex. Then you have the vertex, and then you can go from there. So if you want to find the vertex of this, you have to write this formula. Okay, opposite of b, which is 4, over 2 times a, which is 1. So this is negative 4 divided by 2, which is negative 2. Once you know the Vx, then you substitute that for x in the original equation, and you get the Vy, the y-coordinate of the vertex. So that's going to be negative 2 squared plus 4 times negative 2 plus 3. Negative 2 squared is 4. That's negative 2 times negative 2. 4 plus, or 4 minus 8 plus 3. So this is 4 minus 8 is negative 4, negative 1. So now we have the vertex. The vertex is negative 2, negative 1, like this. Let's graph this. I kind of used up all the space over there, but that's okay. So vertex is negative 2 and negative 1 right there. So that's our vertex. Okay, now this graph is going to be a U or an N. It's going to be a U because A is positive. So it's going to be like this. It's going to go kind of like this, something like that, okay? But as soon as we have the vertex, okay, indulge yourself and just draw the axis of symmetry like this. So let's just label our vertex, okay? It's going to be negative 2, negative 1, right? So the equation of the axis of symmetry is going to be x equals negative 2. Now you need at least 2 other points, right? You can use more points, but you need at least 2 other points to graph this. Now what 2 other points are we going to use? Well, we have to find them. Okay, you can find like a gazillion points. See, all you have to do is plug in some x. What's the value of y when x is 0? What's the value of y when x is 1? What's the value of y when x is 2? Or negative 1, or negative 5, negative 20,000, whatever. You can find as many points as you want just by picking some values from the domain and substituting that in the equation to find the y values. But we want to pick some easy ones, right? Okay, so the easy one in this case is just plug in 0. So if you plug in 0, you get y equals 0. Okay, 0 squared plus 4 times 0 plus 3. So that's gone. So 3. So when it's 0, it's 1, 2, 3. Here's a point. So that's another point. Now, the graph is symmetrical. So if you go 2 this way, and you go up over here to 3, then that's going to be negative 4 and 3. That's going to be another point that we need. And then you can just graph, right? So you can just go like this. Okay. Now, if you wanted to, it's not the very, if you wanted to, you can pick more points and graph more. But that's sufficient. So, and then when you graph this, you should label this, and because it's kind of like mustahab to do that, it's good to do that. And also, I should set a better example for you. You should label the axes, and you should label some of these numbers like that. So that's how you graph. So when you're given a function in the standard form, a quadratic function in the standard form, the way you graph it is you first find the Vx, okay? And from there you find the Vy, and then you plot that and you put the axis of symmetry, and then you find another point, and then the graph disappears. Just kidding. Just moves away, and then you graph it like that. It's easy enough. Okay, now as a review, the vertex form. Now the key thing here is, see, there's a square here. Don't forget that. This is the easiest form because the vertex is given. It's part of the equation. Okay, it's right there. Now, you don't forget that this is a negative sign right there, okay? So if I give you an equation like this, okay, f of x equals 2 times x minus 2 plus 3. That's not, there we go. Now it's a quadratic function. I put that 2 to emphasize. So the vertex here in this case is going to be what? It's going to be 2 and 3. It's not negative 2. Okay, it's 2 and 3 because there's a negative sign there. Here's another example. F of x equals minus 1/2 times x plus 3 squared minus 4. What's the vertex here? The vertex here, okay, is going to be, see, x minus is negative over here. So it's going to be negative 3 and negative 4, right? Because there's a plus there. So you can make it like that. So the first thing is you have to be able to identify the vertex given the function, okay? So from this example, let's just take the first example. We have the vertex, and then it's just as easy as that. So we have the vertex. Okay, let's just do it like this. So it's 1, 2, 1, 2, 3. That's the vertex, 2 and 3. As soon as we have the vertex, we might as well draw the axis of symmetry because we love doing that. It's a good idea to do that usually. So the equation is of the axis of symmetry is x equals 2. It's a vertical line. Now this graph is going to be n, right? No, it's going to be a u because a is positive, see? So we need 2 other points. Well, what points are we going to pick? You can pick any point. You can pick 3 or 1 or 0. So if I pick 3 over here, for example, you can't pick 2. I'll just give you the vertex. Let's pick 3. So f of 3 is going to be 2 times 3 minus 2 squared plus 3. So that's going to be 2 times 1 squared plus 3. That's 1 squared is 1. That's 2 plus 3 is 5. Right, there you go. So it's going to be somewhere over here. Now, and then this was 1 this way. So if I go 1 this way, it's going to be like this. Now, if you wanted another point, you could pick another point. Let's put in 0 over there. So f of 0 is going to be 2 times 0 minus 2 squared plus 3. That's 2 times negative 2 squared plus 3. That's 2 times 4 plus 3. And that is 8, 9, 10, 11. Okay, it's all the way up here. Okay. So now we have our points. It's supposed to be symmetrical. So now we can graph this, see? Go like this to make it kind of like more realistic. Artistic, that is. So this is a U, like this. And then you can label your graph. F of x equals 2 times x minus 2 squared plus 3. Got it? That's easy enough to graph. Okay? What's the minimum of this function? The minimum of this function is 3. Very good. Now, the last one I'm going to talk about then today is the X-intercept form. Okay? That's the X-intercept form. Now, this form is not that difficult either. Some students find this tricky, but once you understand it, I think it's not too bad. Watch this. So 2 times x minus 3, and sorry, I'm going to make this x plus 3, and x minus 5. Okay. Now notice there's no, in this form, there's no square or anything like that over there, okay? Because once you FOIL this, then you get the x squared, okay? But this is a quadratic. And we say, well, I don't see the x squared anywhere. Because, well, once you FOIL this, it becomes an x squared, okay? So now, to graph this, it's not too bad, okay? Now look. Now you have to recognize that this is the X-intercept form, and then just write down what are the X-intercepts. The X-intercepts are here, and they're both minus. You just don't look at this minus here. So S1 is like negative 3. It's not 3. And S2 here is 5. So those are the two X-intercepts. So here it is 1, 2, 3. That's negative 3. That's one X-intercept. and then 1, 2, 3, 4, 5, that's the other x-intercept. Okay, so now we got the x-intercept. Okay, so what do we do now? Okay, well, it's tough to graph a parabola without, the vertex and the axis of symmetry and stuff. So how are we going to find the vertex and the axis of symmetry? Well, first of all, now look at this, okay? You recognize that the A here is positive, so this graph is going to be a U, right? Okay, A is 2, it's going to be a U. So this graph is going to kind of look like this. Or maybe it looks like this, right? Or maybe it looks something like this, I don't know. But whatever it is, it's going to be symmetrical, right? Have you seen a parabola go like that? No, it's going to be symmetrical. It's nice parabola, right? So whatever it is, half of it is going to be this way, half of it is going to be this way. So then you say, well, if it's symmetrical, then the vertex is going to be right in the middle somewhere over here. So if you take the average of these three, okay, the Vx, okay, is going to be the average of these two numbers, okay? So if you take -3 plus 5, that's 2 divided by 2 is 1. So this is the average, okay? So here it is, like, what is it, 4? And here it is 4, see? So equal distance from either this point right here is equidistant or equidistant, right in the smack in the middle of these two. And the vertex is going to lie right there. So this is actually going to be our axis of symmetry right there, in the middle, right in the middle. Where else is it going to be, if not in the middle? Axis of symmetry. Okay? So the axis of symmetry is going to be here. So this is the equation of the axis of symmetry. X equals 1. Got it? That's easy enough. So the axis of symmetry is going to be x equals 1. All right. Now, big deal. Now we found that. But how do we know what the vertex is on there? Well, that's the Vx, right? So we know what the Vx is. So how do we know it's going to be like this, or it's going to be like this, or like that, right? But we know what the Vx is, but we don't know what the Vy is. Okay, well, how do we find out? Well, we just substitute Vx into the function and find out what y is. So y is going to be 2 times, you substitute that in place of x over there. So you get 2 times 1 plus 3, okay, and 1 minus 5. It's easy enough. So it's 2 times 4 times minus 4. Oh, it's a big number. Did I do that right? Yeah, inshallah. So that's 16 times 2 is 32. That's negative 30. Oh, I have to go way down here. Okay, it's going to be way down over here, and then going to come up over here. So the vertex is going to be 1 and negative 32, like that. Let's draw this out. Let's see. So y equals 2 times x plus 3 times the quantity x minus 5. Okie dokie. Let's see what we got. Oh, that's our parabola. See, it's right here. The vertex is this. Okay. Now, if I were to draw the axis of symmetry, see, x equals 1. That's axis of symmetry. Let's go higher mag over here. See that? Look at this. The vertex is 1, negative 1, and the blue line here is the axis of symmetry. If I go up there right in the smack. Now, if I go over here, see, those are the x-intercepts. 5, negative 3 from here. Okay? Now, so that's how you graph these. Now we talked about, let me as a review, let me suggest to you that so far we have talked about this. The quadratic function given to you in standard form. And when you have this, the way you graph this, you find that vertex using this formula, and then find the Vy, and then you graph it. And then we talked about the quadratic function that's given to us in the easiest, or the vertex form. And that's easiest because the vertex is given. And finally, we talked about the graph a quadratic function that's given to us in standard form. In the X-intercept form. So these are the three ways we write quadratic functions. Okay, I know you just did this exercise, but just write this again 3 times if you feel comfortable, okay, or something like that. As long as you know them, you should feel as comfortable writing these as I feel comfortable writing these, okay? This should be really, hopefully, second nature to, so to speak, writing these, okay? Now, I hope you understand this. One last thing I want you to do before I finish and show is this, okay? Watch. If I give you this parabola, okay, like this, and I gave you the x-intercepts, this is 1, and I'm just making this up, and this is like, I don't know, 9, okay? That's the x-coordinate. Okay, it's the x-coordinate at 1 and 9, okay? And I told you that this point right here is, I don't know, I'm just making it up, 0 and 2. Can you find the equation of this quadratic function? And I'm telling you it's a quadratic function. Yeah? Because if I didn't tell you, it could be something like this, you know? That's not a quadratic, right? So, but I'm telling you it's a quadratic function. So how do you find the equation? Well, you know the x-intercept. Well, maybe you can plug them in the x-intercept form. So what's S1? So, well, S1 is 1, S2 is 9. Okay, let's do that. Why don't you just plug it in? So y equals 8 times x minus S1 is 1, and S2 is 9. Oh, there we go, I'm done. Not quite, though, because we don't know what A is. What am I going to do now? Well, we're given another point. If we were not given that other point, we'll be stuck, actually. We won't be able to find the A. But if you're given another point, it doesn't matter which point. We could have been given the vertex. That would have been a nice thing to do, but that's not given. But if you're given any other point, whether it be vertex or non-vertex, we can find the A because we can substitute this point over here in the equation that we have and then solve for A. Okay? So let's do that. So let's substitute this point over here. Y is 2 when x is 0. Like this. That's a 9. So, and then we solve for A. That's easy enough. 2 times 8 times -1 times -9. Okay? So that's 2 equals -1, 9, A. So A is going to be 2 over 9. Okay, it's a fraction. No worries, we can do it. We can handle it. So now we got the A. We're done. Are we? Yes, we are. So 2/9, okay, times x minus 1 and x minus 9. See, here we looked at a graph, and from the graph we derived the equation of this function. And let's just see. Let's try to graph this. Okay, that's 2 divided by 9. Okay, and then x minus 1. Let's do that. X minus 1 and x minus 9. Oh, there it is. Let's get rid of this extra line over here. And there's our graph, see? So those are the x-intercepts. Magnify a little bit more. See that? And look at that. How cool is that? Right? So the x, I gave you this point, I gave you those point, and that's the graph. In this case, if you wanted to find the vertex, you would take the averages of those two. That would be the Vx, and then plug that in an equation, and you can find the Vy if you wanted to. So here was an example of deriving an equation, deriving a function, given some information like that. That was easy enough. Inshallah, next time we'll explore some of this topic and review. Until then, as-salatu was-salamu ala rasulillah, walhamdulillahi rabbil alameen.